Now, after if we identify that, okay, this is the wireless sensor network, not MANET or VANET and other things, and we also identify that, okay, what is the application. So if we have our applications, then how we can build a wireless sensor network, what components are required for making a wireless sensor network. So that four basic components are there. One is node architecture, whatever the node wireless nodes you are using, that is the very first component. Then how this node can data aggregate, that aggregation algorithms, protocols and other things comes into the picture. Then if aggregation is over, how to route this data to the sync node, and finally what communication protocols are required for communicate this information to the sync node. So if we think about the deployment of wireless sensor network, we need to take care of all these four dimensions. So very first we comes to the node architecture. So when we talk about the node, as we already seen that wireless sensor node, which is the small in size and low power consumption, because these are the battery powered. You are not able to change the battery, or you are not able to charge the battery very frequently, very periodically, such as the forest monitoring. You are not able to once again collect your node and replace or recharge your battery. So that means that whatever the nodes you have designed, that must be the low power consumption and an energy efficient node, and also small in size, and autonomous devices are there. So say for example, they automatically change their mode, that okay, these are the normal, these are the power saving mode, or some vehicle monitoring in the night time is not required, only in the daytime is required. That means some intelligence, some autonomous devices automatic is required in that case. Now if you open that node, if we whatever the node is there, if you open that node, you can find out these main units. So this is the picture of block diagram of this wireless sensor node. So if you deploy this node, so like this one, this is a node and they have the four main unit. So if I open this node, one is the controller, which is also known as the processing unit, and they process the entire data, whatever the data is collected from the sensor, whatever the data is comes from the other nodes. They process this data and they transmit this data using the transmitting unit. So this is for transfer the data from this node to the another node. And how they can collect the data? With the help of sensing unit. So sensing unit, they have the sensors and ADC, analog to digital converter, and other units are there. So the sensors, they have the sensor, they collect the sensory data and transfer to the controller. Controller do some processing and use the communication or transmission unit to transmit this data to the others. Of course, the power source is required, such as the battery and other things, how they can take the powers and other things. Sometimes this is the they use some solar cell or solar batteries are there, so solar plate and other things are also the part of the power source unit, how they can do. Yes, of course, while we are doing the processing, definitely we need to use some temporary storage. So temporary storage or some external memory is required in two cases. One is that if you have some data, you process the data, your data collection speed is high as compared to processing speed, definitely you need to store the data in somewhere else. Another reason is that these are the relay based. That means the data comes from the other nodes to this one node, and this node can forward this data to the other nodes. Maybe possible these nodes collect the data from the various nodes. Then of course their communication speed is not as fast as their collection. That means they collect a huge data, so definitely they need to store the data from somewhere else as a temporary. So memory is required for their own data, and the memory is also required for the data from the other sources. And finally the clock is required, but the clock, sometimes clock is required, sometimes clock is not required, depends on your application of wireless sensor network. So when we require the synchronization, that means when you send the data you need to time clock, and when you receive the data, time clock is required. If time difference is more than the threshold value, they discard these packets and other things. If such type of phenomena is there, then clock is required, otherwise the clock is not required. But initially these four units are the main unit: sensing unit, processing unit, transmission or communication unit, power source unit, and the memory is required for store the temporary data and so. Right now, what else is there, that microcontroller itself is sufficient. They have the memory unit inside the microcontroller or nearby the microcontroller, like this one type of solutions are there. And clock is for synchronization or sync up these devices. These are some major players, industry players. They design or build the wireless sensor nodes, wireless sensor network nodes. And microelectronics, ST microelectronics, Texas is that means they have the numbers of sensor nodes in the low cost and high cost, and everything is there. Even they have numbers of sensor nodes for educational purpose. So that is very big series of the sensor nodes in this Texas. Silicon is there, Bosch is there, and Liblium is also there. They also have the numbers of agriculture, or these wireless sensor node kits are there for agriculture, for city monitoring, city pollution monitoring, smart parking kit, and other things. So these five are the major players, the companies, the product the wireless sensor network nodes. So if you want to purchase, then definitely we need to go to the all these sites and check that okay, which node is suitable for our own application purpose in terms of the cost, in terms of your requirement, whether you required a high energy, you required a small in size, you required very robust, all these things are there. So here in the picture we can see that okay, this node, they have the USB connection, and this node is the powered by the two cells like this one. So all these are the requirement, that what requirement is there, we can pick the node and select the node. So definitely we need to go to these company sites to check that what is the availability is there. Now, so this is the node, that node architecture that we have seen. They have the sensing unit, processing unit, communication, power unit, memory, and clock. So now we talk much more about the sensing unit. So here we have seen that the sensing unit has the sensors. So what is the responsibility of the sensing unit of a wireless sensor node? Of course, they need to detect, they need to monitor, they need to observe the physical or the environmental parameters. Okay, they need to detect the physical parameters, whatever the physical parameters is there, and the environmental parameter. Now, a question comes into the picture: what is the difference between physical and environmental parameters? Of course, both things can detect with the help of the sensors. Sensor is always there, but what is the difference between these two? So, physical parameters sensing measures the physical conditions in a particular environment. So, such as the temperature is the physical quantity, and the pressure. The pressure means the gas pipeline. If more pressure is there, they can detect like this one. Humidity is the environment. Humidity in the moistures like this one in the soil and other things, and light intensity is also physical parameters. Sound level is also a physical parameters, and the motion detection and other things. So all these are the physical parameter that is detected by the sensors which are attached with the sensing unit in a node. But environmental parameter is also important, and yes, these wireless sensor networks are capable for detection of the environmental parameter and changes in the environmental parameter. So, such as the air quality changes. So, if change in the air quality, some pollution level is high or low, these are the environmental parameters. Water quality, soil moistures, and the radiation levels. All these are the environment nearby our environment, such as the air, water, soil, radiation level. All these are the environment nearby us. So these are the known as the environmental parameters, and they are detected by this one. So if you take an example that this physical parameter is the temperature sensor can use to measure the temperature in a room or the greenhouse. So here in this case you need to measure the physical parameter, but if a gas sensor can use to detect the presence of the harmful gases in the air, so these are the air quality direction, that is, this is the environmental parameters, not the physical parameters. So right now the sensors are exist for both type of the measurements or the measures, and here we can see that classification of the sensor, how we can classify the sensor, because the sensors are huge sensors are there. So we are not able to classify based on their name. So definitely we need to use some terminology for classification. So based on the sensing technology, how they can sense and what phenomena they use for sensing purpose. So if the sensor, they use the resistance for the sensing purpose, that means whenever some changes or the occurs inside the temperature or inside the environment, then definitely they can detect. So that means the resistance change related sensors is in that category goes in the resistance sensor. So such as the example is the temperature sensor. So whenever the temperature change, then definitely they can detect and they can inform this is the resistance. Or the light sensor, some light intensity is there, they can detect the light intensity and transmit this one. So these are the resistance. So whatever the resistance in the wire or resistance inside that one, if they change with the because of the temperature, because of some light, then we can put the sensor in this category. And the second one category is the capacitive sensors. They have some capacitance and change the capacitance based on the value. So say for example, humidity sensor or the soil moisture sensor. So that is they have the capacitor sort of thing. They store some values and measure that values like this one. So different from the resistance, they use the capacitor. That's why they go in this capacitor. Third one is very interesting. They use some coil sort of thing, inductive sensor, some proximity sensors. So they make some effect in this region. If someone obstacle comes within that effect, then they can detect. So this is the inductive effect or some coil measurement sort of thing. So these are the sensors. They are the inductive sensors. They can detect the proximity values with the help of this interference region. So if there is interference region created, if any one obstacle comes within that interference, they can detect. Finally, that is the fourth one category is the optical sensors. So these are some optical diodes or photon is there, is some light intensity that goes on the photons, then they can detect. So these are the categories based on the sensing technology. So broadly we can classify into sensor technology into four categories. One is the resistance based, capacitor based, induction and optical sensors. And based on these categories we can easily classify the sensor in a different field. Yes. Sometimes literatures they say the sensor can deploy can classify or divided into based on the perimeters they measure. So say for example, temperature sensor, they measure the temperatures. Pressure sensor, humidity, light, sound, chemical, motion and proximity sensors. So this is their name itself. So here we are not using some that means technology. We use what they are doing. So if they measure the temperature, say they're the temperature sensor. If they measure the pressure, we can say this is the pressure sensor. So this is the another class of the classification, and these are some pictures of the sensors that okay, this is the smoke sensor because they detect the smoke. Alcohol sensor, they use the alcohol sort of thing. So this is the touch sensor. Because, so based on their application, we can name the sensor. Then we can say yes, these are the classification of the sensors. And right now, because of the low cost of the architecture, low cost of these type of the devices, these sensors are very cheap right now. Because the architecture is very cheap and very nano size, so the cost of these sensors are very less as compared to earlier, and that category. Now we go to the another class of the sensor classification. So some literatures they say that no, based on the that means whatever the technology you have built that is not a correct way, and or this one. So they can divide it very easily into two categories. One is the analog, other one is the digital. If a sensor they continuously transmit their data. They continuously transmit their data without any interrupt or without any delay. So in that case, we can say this is the analog sensor. Continuous values you find out. Of course, value is high or value is low. So say for example, light intensity sensor, they continuously transmit the light intensity. So sometimes sunlight is high, then their light intensity is high. If the sunlight is less, then definitely light intensity is less. So this is the continuous values are there. So such type of the sensor goes in the analog sensors. Other category or the different category, the digital sensors, they have only two state, either on and off. So proximity sensor is the digital sensor. So say for example, door open and close. So that is on and off. Okay, so if one sensor is for door open and close, that means in that case we can say this is the digital sensor. Why? Because they generate only two values, binary values, 0 or 1, like this one. So this is a very this is very easy that this is very easy to classify that the sensor into the two categories. One is the analog sensor, other one is the digital sensor. Of course, based on their application, not based on their perimeter measurement. Here we measure the perimeters. Here we have the application. So if the sensor is useful for the environmental monitoring, then we can say these are the environmental sensors. So this is the another class of classification. If the sensor is useful for industrial purpose, we can say industrial sensor. If the sensor is used for medical sensing purpose, then we can say this is the medical sensor. So this is the application based sensor classification. So these are the non-classification of the technique. So it depends on the that means literature. It depends on your application that how you can classify. So but that means most of the people they say the sensor based on their name, that what perimeters they detect. We can take that sensors like this one. This is the last one classification, that a very interesting classification, that we can classify the sensor based on their resources, based on their that means energy, whether they have some energy source or not. So active sensors, one is the active sensor, other one is of course the passive sensors. So active sensors require an external source of energy to generate their own signals that is used to probe the environment. So this is the active sensor. They generate some sensor, the energy, and reflect back that energy, then they can detect the motion of the birds and other things. So active sensor, they have their own that means external energy source for generate the signals, and based on the reflection they can identify that whether some environment monitoring and other things. So radar, sonar, radar, all these are the that active sensors. So this type of active sensor, they are the power hungry. They need a huge energy, because they are the that means have the energy, then they can only generate the signal. So power consumption is very high in this type of the sensors. So if you deploy the such sensor in the forest area, then definitely the life of the wireless sensor network is very less, until unless you use the solar power and other things. If they are also have the solar plates and other things, then it is good. Otherwise, their life is very less as compared to passive sensor. So passive sensor, they are not required any external source of energy, and they depend on the natural energy sources such as the sunlight. So when the sunlight is on the earth, then we can detect like this. So these are the passive sensors. So here we have no such our own energy source. Whatever the energy source is the sun, they have the heat or they have the sunlight, then we reflect it and we can detect like this. So image sensor or the camera sensor, infrared sensors goes in this category, the passive sensor. So these are the classification of the sensors that based on their application, based on their technology, based on their working principle and all other things. After the sensing unit, we comes to the processing unit. So assume the sensors is already there. Whatever the classification is there, you have the sensor. If you have the sensor, then definitely you can detect the environment parameters, or that is the perimeters. Now these perimeters or these values transfer to the controller, not the controller, that is the processing unit, transfer to the processing unit. Now the duty of the processing unit is to process the data, so that we can see that how it works. So the responsibility of the processing unit, the responsibility of this processing unit is to process and analyze the data collected by the sensing units. So there are two things. One is the processing, another one is the analyze. Before that means the very first step is processing is required. Say for example, data pre-processing. Okay, numbers of values are there. Some is very up, downs, noise is there. All these things are there. So or some analog signals are there, some sort of thing. So need to convert into one form to the another form is the processing. And once they convert the data into one form to the another form, after that we can do the analysis. So both responsibility is the processing unit, process and analysis. So say for example, you have the wireless sensor network for forest fire monitoring. Fire, that means the temperature is more than a threshold value. So if some fire is there that 90 degree or 95 degree temperature or 100 degree, assume that whatever value is there. So processing, first they filter out the noise and other thing. Once they have noise-free data, then analytical or the analysis, they say that whether the temperature is greater than the threshold value or not. If the temperature is greater than the threshold value, this is the part of the analysis and not the part of the processing. So analysis says that yes, the temperature is the greater than the threshold value, then we can relay this data to the other nodes. Otherwise, we can drop this data. Why? Because that is the normal, there is no fire at all. So processing for pre-processing and other work, and then after comes to the analysis, whether it is required or not. If required, then we can do something else, we can drop it. So this is the responsibility of processing unit. Another responsibility of processing unit for managing the power consumption. The wireless sensor networks, as we already seen, that deployment in the forest area, deployment on the river and other things, and these nodes are the battery powered. Battery usually not replacement or rechargeable mechanism. So in that case, definitely whatever the battery is there, that is their lifetime of the node. And lifetime of the node directly impact the lifetime of the wireless sensor network. If some nodes goes down, then definitely black hole comes into the picture in forest area. Then you are not able to monitor. Then you are not able to successfully monitor in the forest fire. So battery goes down of the some nodes, directly indirectly they can kill the wireless sensor network. They are not able to sense perfectly the entire region, and they are also not able to communicate this information to the sync node. If some hole is there, no communication sensor node is available because of the power. So power consumption, managing the power consumption is also a big responsibility of the processing unit. So how they can reduce the power consumption, this is their responsibility. So say for example, if we take an example, analysis. So you can check that whether the temperature is more than the threshold value, then only you can transmit this data, else just drop it. So if you drop the data, we are not, we can save the communication energy, and whatever the power consumption by communicating this data, not only the communication energy of that node, but also the communication energy of the relay nodes. So this is the responsibility of the processing unit. So whenever you select a processing unit, whenever you burn your code in the processing unit, you need to worry about processing, what pre-processing is required, what analysis is required for power saving. Another example of the power saving in the analysis is the data compression. So if you have the huge data, why you transmit without any compression? You can use some coding approach. So say for example, if your data has a very long string, better you can convert in some hash table sort of thing. All these things work in especially for the power consumption, especially for the analysis purpose. Yes, as we already seen that the communication, So responsibility for communicating the analytical data with other nodes. So as we already seen that if you that means this the processing unit is the responsibility for communication. If your data size is very big, your data string is very large, and your communication protocol speed is very less, that means they support only some bit per second or byte per second like this one, okay, BBS like this one. So in that case, this is the responsibility of processing unit to compress the data before transmission of the data. Otherwise, processing unit, they break the data into multiple packets and you can transmit this packet sequentially one after another. It's a huge communication overload. So the throughput goes down. So it is good that we can compress the data, we can filter out the data before transmission of the data. And who else can do? This is only the processing unit can do all these things. And processing unit also responsible, and they can also take care of the executing the source code or the software that control the behavior of the node. Here behavior of the node is not only the related with the data, but also the health of the node, but also their structure or their state of the node. Say for example, they have very limited battery power. Now they know that they need to survive next 5 days. They see that, okay, in the night time I have very limited data. Why they are working on the night time? Better they can go in the sleep state in the night time and active in the daytime. Similar is the forest fire monitoring. Why they are detect each and every second data. If they see that, okay, my battery lifetime is very limited, residual energy is very limited, then what they will do, they can use some time window, more time window. So in place of each second detection of the temperature, they can detect the 30 minutes, 25 minutes, 20 minutes like this one, so that they can save the battery power and execution of. So these are known as the behavior of the nodes. That means they change their behavior, they change their sampling rate like this one. And these are not the behavior of the data or the behavior of the sensor working their own, but the node, they change their behavior for detection. In place of 1 second, they can change in the 30 minutes and so on. And all these things done with the help of software, whatever the framework you have run on that node. So this is the responsibility of the processing unit to control that software or to change the software and other things in that case. Now, when you choose the processing unit, when you have the option that, okay, you can select this processing unit or that processing unit, what keep in your mind? So when you select the processing unit, when you go to the PCB board designing and other things, you already select the temperature sensor. Now we work on the processing unit. So first thing about the application, what application is there? Your application is some very crucial application, or this is the normal application. If the normal application, why you are selecting a high processing unit, which consumes huge energy, which cost is very high. So if your application is very normal, that means that is not a very crucial application, some not life and death matter like this one. So in that case, you need to select the process unit which is low cost, which is the simple, which consumes a very less energy. That type of processing unit we need to select in that case. And also that application is depend on the, that means requirement is select the speed of the node. Say for example, if your requirement is very high, that means you need to detect and you need to process, you need to analyze the data within a time period, whatever the time period is, the hard real-time system like this one, and very limited, then definitely you need to select the processor which is the high-speed processor. If your time limit is so far, so that means your data is very limited, you have sufficient time. Say for example, that means soil moisture monitoring in the agriculture field, that means you have sufficient time, you are not very time crucial. So you can use the slow processors, whatever the processor is, their speed is the slow, then that time we can select that type of processor. Power consumption is also there, so you need to select the processor which consumes less power, but don't compromise with your requirement. So if your requirement is high speed, if you select the processor which consumes very less power, very slow, then definitely. And form factor, that means what is the shape is there, what is the packaging and other things comes into the picture, or what is the size is there, whether this node or this processing unit sufficient size or very bigger size that is not put inside your devices, then nothing to be useful. So these type of factors you also need to consider when you select the processing unit. Now in the wireless sensor network, types of the processing, similar as we have seen the types of the sensors. So processing units also have the different types. And of course the types depend on various factors. So very first, a very simple, a very small is the microcontroller. Okay, this is very first, that means very simple, which is small in size, very low cost, low power integrated circuit. They contain a microprocessor, a small memory, very small memory, and some other component, whatever the components are required. So this is an example of the microcontroller. They have the microcontroller, and And they are commonly used in the wireless sensor network due to the low power consumption and small in size, and also because of the low cost. You know? So an example is the Arduino. So as we already, that means we all know about the Arduino board. So they have the microcontroller, and this is the small size, power consumption, integrated circuit. All these properties are there. Now we go in a one step advance. So every time this type of the low processing, small size, very slow is not sufficient for your application. Then you need to go to the DSP, digital signal processors. So in that case, whatever the nodes are there, you need to put the digital signal processors. So these are the specialized microprocessors, not a normal microprocessor, that is for application purpose design or driven microprocessor that are designed to perform the fast, efficient calculation on the digital signals. Calculation is here based on your application. So various that means microprocessors are there, or based on their application. Commonly used the this type of the digital signal processing, the micro wireless sensor network required signal processing capability, such as audio and image processing. So say for example, if you want to use some nodes for tiny machine learning sort of thing, or some prediction based on the image or based on the audio, this type of Arduino or this type of the microcontroller is not sufficient, then definitely you need to go to the digital signal processing type of the board. So SensiBLE is an example of the, right now it's a very well known in this category of the digital signal processing. Its cost is also very less, and it is a good example of using a little bit more advanced in the microcontroller, that is the digital signal processing. They also perform some signal processing capabilities, whatever the requirement is there. We go in a one step further advanced, that is this DSP is also not sufficient. In that case, you need to go to the field programmable gate array, FPGA. Okay, LoRaWAN use this FPGA right now. This that IC, they have this. This is a programmable logic device that can be configured to perform the specific function, whatever the function is required. And the beauty of this solution is that high speed processing or customized logic gate. So whatever you required, that you can customize based on your requirement. And advantage is that high speed. So this is the third step. One is very small, then you can go to the microcontroller. Then if you use the signal processing such as audio, video, or audio and images, video is little bit high in wireless sensor network, usually not support, and audio and image is possible, so DSP. Then we go to this FPGA, that is high speed and customized based on your requirement. So already available in the market, the board is already there, you need to attach the sensor and use it perfectly. Last and final is, that is the SoC, system on chip. This is the complete system sort of thing, and an integrated circuit that combine the multiple component on the single chip. Because they also consume the low power consumption and small size in this one, and this is the example of STM32 is the example of the system on chip. So the difference between these two is that they have the multiple component, not only that processing unit, but also they have the other component in that case. So these are the four categories. Based on your requirement, you can select and use it. Now, how we can select not only the application, but also the other parameters also affect when you select which unit is suitable for my application. So based on the application requirement, so if you have the four options, all four options are available in terms of your budget, in terms of your size, in terms of your requirement. So what parameters we need to consider when we pick one out of these four? One is the application requirement. What application is there? One is the processing speed. If you need a high processing, definitely you need to go to the low range, and you need a memory, you need a power consumption, or you need a signal processing and other things. So if you require the signal processing, then definitely you need to go to the digital signal processors, not the microcontroller. So this is depend on your application requirement, what application is there. Based on that one, you can select the unit. The second one is the power constraint. That means whenever you select that, definitely you need to worry about the power consumption. If you are not able to replace your battery, if you are not able to charge your battery again and again, so when you select, you need to worry about the power constraint, that how much power is there, what power sources is there. Another important is the available resources. What software library is there? Say for example, if you use digital signal processing, and right now you go in the market and purchase in the other way, this one or that one, they are not support whatever the libraries you have built, whatever the software design you have designed, because your library requires some signal processing libraries also. So in that case, definitely you need to select the controller which support your libraries, not directly support based on their processing or based on their cost. And of course, the form factor, that means what packaging is there, whether you can put this unit inside that on the PCB or inside their bags and other things. So that is also an important factor that when we select this type. And test and optimization is that is the last one, that how you can configure your perimeters. Configuration of the perimeters, that means change the perimeters. So if your board is support to such type of the configuration optimization or not, if you required. So say for example, if I need a dynamic perimeter changes in the communication protocol. So whether this type of the controller is support the dynamic changes or that type of the controller is support the dynamic changes in the perimeters. So these are the some that means selection criteria that when you select a unit, what keep in your mind. And apart from this, numbers of other criteria are there, but these are some criteria that is there. Form factors is also covers the high temperature and other things. So say for example, if you use for that means fire monitoring, so fire is there, that means how your node can survive. So that is also the part of the form factor. And similar is the agriculture water resistance, that is also comes in this category. So you need to have your requirement that okay, water resistance and other thing that is there. So up to now in the node architecture, we have covered the sensors, that what is the sensor, what type of the sensor, classifications of the sensors and others. We have also seen the processing unit, how they can process the data, what data is there, how they can solve these problems and other things. Now we need to communicate this information to the node. We need to translate or transit this information to the other nodes. So because of that reason, this node also have one communication or transmission unit to transmit this data out to and receive this data from the other nodes. So main responsibility of this unit is to transmitting and receiving the data wirelessly. Because we talk about the wireless sensor network, so wireless automatically comes into the picture. Here interesting thing is that this unit is responsible for both transfer as well as the receiver purpose. Okay, someone is transmit, then I can receive this information. So the one single unit is there for transmission and the receiver purpose. And they consist of the radio frequency transmitter that can communicate with other nodes. So that means they have the fixed RF radio frequency for communication, for transmission of the data inside that one. And once you select or once you find out one unit, you need to keep in mind that the power consumption, that it consumes huge power. So whatever this antenna designing, this is the PCB printed antenna in that chip like this one. So what power level is there? If the power level is more than what you are expecting, then definitely you need to select the other unit. What memory is required for storage, for communication and for receiving and processing like this one. So all these things comes into the this unit part, that how to select. We need to worry about all these power unit and other things. Now feature of this unit is that means when we select or what features are required, what qualities of services are required in this unit is as follows. So here that is the communication protocol. So each node they have communication capabilities, but they use the different communication protocols. Say for example, some nodes they support the Bluetooth, some nodes they support the Wi-Fi like this one. So when you select this unit, you need to check that which protocol is suitable for you. So that means specific or given protocol is specific. That means say for example, your other nodes they support the Bluetooth, then definitely you need to use the unit which is the Bluetooth enabled. Otherwise, how you can communicate this information to the other nodes? So communication protocol is fixed with respect to the unit. So when you select a unit, when you work on the unit, you need to check that okay, this unit supports whatever the communication protocols you are using, your other nodes already used in this protocol. Second is the frequency band. So these nodes they have, that means this unit they have the different frequency band, 2.4 gigahertz, 5 gigahertz like this one. So the frequency band is the different. So when you select this unit, you need to worry about that okay, whether this frequency band is suitable for you or suitable for your application or not. Sometimes that we go to the spectrum sort of thing. This is the license spectrum, this is the license free spectrum like this one. Another is the modulation technique. Since that node is the large node are there, if you are not using modulation technique, you are not able to transmit the multiple data simultaneously. So modulation, they change the format so that you can transmit the data simultaneously and nodes can receive, they demodulate and they can extract that information. So such as the frequency shift keying, FSK or the PSK modulation technique, and change the data. But the important thing is that whatever the nodes are there, if two nodes they can communicate, they have the same modulation technique. Then only they can detect, otherwise they are not able to work. So whenever we select the device, we need to worry about the neighbors. That means how we can share this information with the others. So modulation technique is same as the existing. Another important factor is the data rate. So if you generate a large data, if you attach the 10, 12 sensor inside the node, definitely you need a high data rate unit. Otherwise, how you can transmit your data? That your memory is also limited. So after some time, that data goes down. Why? Because your capacity of the communication is not sufficient. So in that case, your data goes down. So data rate is also an important factor when you select this transmission unit, and it must be able to transmit and receive the data at the required data rate for the application. But usually we assume that wireless sensor network, they have a very limited data. That means not a very huge data expectations in that case. But yes, they are able to. Last one is always the power comes into the picture. Every unit they have the power constraint or power consumption, because the power hungry is nothing to be useful. Someone they attach the that means Wi-Fi or some other communication protocol in wireless sensor network, they consume a huge power, then that is nothing to be useful, because we are not able to replace the battery or recharge the batteries.